Hey, welcome to a brave cohort of the Democratic Women's Club of Gainesville. This is, you are to be commended because this is a difficult program to listen to. And I promise you that we can do this. It just takes effort and policy and dogged determination, which I know this group has in spades. So our topic today is the water will come. Let's see if I can get my screen to share properly and the slideshow to start correctly and see what we can get. Okay, very good. I want to point out this blue ribbon under the title of the program. And this bright sun is the sun coming up over Earth. This was the 1968 view the astronauts saw, the very first Earthrise. I know we've just seen one from Artemis, but this was the very first one. And I like to use this Al Gore slide as a reminder that this thin blue ribbon is our atmosphere. And until we started pumping tons of pollution from burning oil, coal, and gas into the atmosphere, this kept us from, kind of kept us in a Goldilocks climate. It was just enough carbon dioxide and other greenhouse gases to keep us warm. What's been happening, and we're going to talk about that, is that carbon dioxide is trapping heat like a heat trapping blanket. And most of that heat is going into our ocean. And that ocean heating is going to lead to water will come, but from where? And although this program is somewhat tilted towards the terrors for South Florida and the lower part of our state, there are implications for us here in North Central Florida as well. We're going to take a look at historical Florida 120,000 years ago till present. And we're also going to look at the probable and almost certain future we will face if business continues as usual. We do not keep fossil fuel, oil, coal, and gas in the ground. And we'll close by looking at what can we do. I do want to make a point that the title "And the Water Will Come" is actually borrowed from a book by Jeff Goodell, written about 7 or 8 years ago. Excellent reading, paints a very good and very accurate picture of what's going to happen with South Florida. I also do want to give credit to the University of Miami's Dr. Harold Wanless, a huge debt of appreciation to him for his dedication, his research over 54 years of telling the sea level rise story, for his persistence in the face of governmental dismissal of his science, most recently, October a year ago, at the Regional Compact for the 4 South Florida counties. He gave them his current research on the possible sea level rise for South Florida as being different from global sea level rise, and they dismissed his science. So I have a prayer. I pray that you take what you learned today, and in honor of Harold Wanless and all the other brave scientists who continue to tell the story, that you will consider taking what you learn and sharing it with people in your circles. Also, I'm going to send to Doris 2 of his 10-minute lecturettes on heat and sea level rise. And this is from where I've taken much of the science in this very short program. So let's take a look at what's going on. This is a history of carbon dioxide levels from 800, when I look sideways, it's because I've got a second screen going, from 800,000 years ago, BP is before present to the present. Here's where we were in 2010. In a minute, I'm going to ask you to kind of just jot in your mind a mental answer. What do you think the parts per million, which is this column right here, of carbon dioxide were in the atmosphere back in July, just a couple of months ago, July of 2022? How do we know what the carbon dioxide was? We can take ice cores, we can look at tree rings, we can look at lake sediments. And those, when we look at those 3 things, it's pretty evident that we've had, as you can see in these peaks, areas of great warming when the parts per million reached maybe to 300 parts per million. and times of great cold, and that's where the carbon dioxide was the lowest. So go ahead and make a mental note. Where do you think we are right now today in terms of July? 421 parts per million. When I was born, we were at 310, already over the year I was born, already over the highest amount we would have been able to measure in the last 800,000 years. So the point of this, when you hear people say, well, global warming is a natural phenomenon. We've always had heat and ice. That is absolutely true. But over 100,000 year spans, you can see each of these peaks or valleys is about 100,000 years. We've done this in the last 150. So we're changing color schemes here. The blue is now a carbon dioxide, and you're already familiar with that. Here we are. It's called the hockey stick, by the way. It kind of looked like, here's the paddle part of the stick, and here's the stick. The red is temperature. So the same way we know what global concentrations of carbon dioxide were, we also can guess on what the heat levels were. And I'm going to ask you again to think for a minute what you see right here. Something look kind of funny to you? Can you see how pretty much heat and carbon dioxide moved in lockstep? Whoops, sorry, I jumped ahead. Don't look. I'm hoping that you're noticing that carbon dioxide shot way up, but the heat is still on its way up. And so what's going on? There's a fact that the oceans have been sucking up this extra heat for us. And here you can see, again, a concentration. We're only going back 400,000 years now. You can see that carbon dioxide concentrations, when they are high, sea levels were also high. And here's the Industrial Revolution, 1750 or 1850, depending who you ask. And we've gone straight up, straight up, straight up. And so today, as I said, we're at 421 parts per million. By the way, under no administration since 1988, Republican or Democrat, has this level gone down, no matter what the White House has said. We are all equally complicit in not stopping burning of oil, coal, and gas. So where's it coming from? Well, some of it is burning forests, and there's a lot of that going on to clear pasture land for cows, particularly in the Amazon, which is a whole other program. Oil production, lots of flares. Believe it or not, air transport and boat transport burning oil. We burn crops, sugarcane in Florida. Fertilizer is a big producer of methane and other greenhouse gases. Transportation of our trucks and our cars is a big producer. Burning coal is killer. Coal is really, really, really dirty. And yes, you'll hear natural gas is a cleaner way of burning, and that is true once it gets to the plant and is burnt. But if you look at the amount of leakage and the cradle to grave of bringing natural gas or coal to a burning an energy plant, they're equally bad. Industrial processes, agriculture, industrial agriculture, a very big producer of methane, which is also a greenhouse gas producer. So there's really a tremendous amount of sources of greenhouse gas, but by far the largest source is the burning of fossil fuels. And you can see the trajectory going up in an exponential, reckless, and very dangerous way, adding more and more pollution to create more and more of a heat trapping blanket. I like to show this graphic from NASA. Let me point you to this corner, and I'll replay the animation one more time. You can see the Earth cooling and heating. The blue is more winter and the yellow is more summer. Watch what happens as we move into the decades after my birth. And here I stop and ask you again, do you see something funny about this graphic? Can you notice how much warmer the northern parts of the northern hemisphere are than even the warm parts of everything below it, and the heat wave in Antarctica? This is caused by something called Arctic amplification, and we're going to talk a little bit about what's happening there. We used to think it was heating at twice the speed of the rest of the land surface. We now know it's heating 4 times faster. This is actually quite terrible, and you'll see that in a minute. I promised you I'd replay the animation again, and you can see the decades going on. And the last 5 years of recorded history were the warmest in the modern record. So where's it going? Well, a little bit of the heat is taken up by our land, but most of the heat, more than 93% of it, is going into our oceans. And that ocean heating has a very big implication. Oops, sorry. Until about here, 1993, the ocean level, the sea level was going up. It was going up somewhat slowly, millimeters per year. And it was going up primarily because of a phenomenon called thermal expansion. You can see that when you heat a pot of water on your stove. As water heats up, the molecules are moving more rapidly and it takes up a little more space. So all that heat in the ocean is changing sea levels. It's also changing ocean chemistry. We're not talking about that today. We can come back, you can invite me back, and I've got a great program on what's going on with ocean acidification. But for today, let's just deal with the oceans and sea level rise. So you might notice that since 1993, 30 years of sea level rise, there's an acceleration of the sea level rise. Before, as I said, it was mainly expanding warm water. And about 30 years ago, ice melt from Greenland and Antarctica entered the picture. And it is this melting ice that you have to be aware of. Scientists badly miscalculated how slowly polar ice would melt. The scenario is much worse, much faster, and it's coming in pulses and not gradually. It's coming from the collapse of ice fields like this beautiful, beautiful glacier in Greenland. And you can see from this graphic that it shows you the extent of ice melt. And if all of Greenland were to melt, and it's probably on its way to doing that, even if we stopped burning fossil fuels right now, because the heat is trapped in our atmosphere and it's baked in, unless we find a way to suck the carbon dioxide out of the atmosphere, sea level would go up about 23 feet. Won't happen tomorrow, but this is pretty serious shrinking of ice sheets there. Something interesting is going on. It's called moulins, and this is when the water from the top part of the ice melts and it starts to run down, and it creates these canyons in the sheet ice. And these glaciers can be 2 miles thick. So you can see in this graphic that it forms a lake and water drifts down. And now you've got 2 things happening on this block of ice. And I like to tell a memory of mine, how my mom used to defrost our old freezer, turn the refrigerator off and get a tea kettle of hot water, and she'd pour hot water all over the top of the ice stuck on the bottom of the freezer, and take a spatula and move the hot water under the big ice sheet that was in our freezer. And she would also take a hairdryer and blow warm air over the top. And little by little, you could crack the big sheets of ice in our freezer and lift them out and put them in the sink. It was actually kind of fun. But what's happening here is not so funny. Warm water is coming in from the ocean and slipping in under the ice sheet, which is lubricating it and allowing it to move. These big cracks that are happening in the ice sheets are going to allow it to break into pieces much faster than originally thought. They can fracture. And this is a picture from the sky of what's happening on top of the ice. You can see that there's a lot of soot. Once the top layer of fresh snow melts off, you have decades, centuries of volcanic ash, soot, other air pollution, forest fire dust, all making the ice dark, all creating a heat trap for the sunlight hitting the ice. Ice is supposed to be white, supposed to reflect and bounce sunlight back out. But what's happening now is it's dark and it is taking heat in. Something to keep your eye on in the news is the West Antarctic ice sheet. You can see that there's a kind of a peninsula of ice here, and it is anchored by a mound of mountain underneath. And that mound of mountain is holding back the ice sheet. As warm water comes in under that, that also will, just as we saw in the Greenland ice sheet, will start to fracture. And when and if it fractures all the way back to the top of the mountain holding the glacier back, we may have very rapid glacial descent into the ocean, and that would be really, really bad. So this warming seawater is causing accelerated melt in the fjords, and if the West Antarctic ice sheet melts, sea level will rise an additional 25 feet. It could happen because we saw in one of the first slides that it has happened before. That would result in about a 10-foot global sea level rise, and Florida will have it worse. So depending which scientists you talk to, and this is Kenneth Miller of Rutgers University, this was 2012, the last time carbon dioxide levels were above 400 parts per million was about 3 to 5 million years ago, and the sea level was 70 feet above present level. And well, we're okay, here we are, Alachua County, but Miami, gone. So let's look back in time. This is a little bit of paleontology, and for those of you who don't know, that is Phyllis Saarinen hobby, and she does a great job explaining it. If we go back 120,000 years ago, the world was much warmer, and sea level was about 18 feet higher than it is now, and half of it was from the north and half of it was from the south. So there you can see, we're looking at the outline here, and this is Florida. And I guess here we would be up in Gatesville. And then an ice age started. Remember I said there every 100,000 years or so. 18,000 years ago was the last maximum of the glacial period. And look how fat Florida got. The shelf, continental shelf, was very, very much wider than it is now. And the sea level was 360 feet lower than it is now. So you could walk all the way out into the Gulf of Mexico there. And here's where we are more or less today. That shelf, as you see, is now underwater. How did that sea level occur? Well, it occurred because we've got thermal expansion, and we're going to talk a little bit about the extra risk that South Florida has. Don't let all the numbers on this chart freak you out. I just want to show you. This is a NOAA projection of time, and they give you a high extreme projection, a high projection, an intermediate projection. The lower projections have already been exceeded, so there's no point even showing those to you. And they're looking at global mean sea level, which means half the sea level in the world would be more and half would be less. So they're looking at between 5 to 8.2 feet of sea level around the globe by 2100. Note the word global, because we're talking here about Florida. To understand the possibilities in Florida, you've got to project for region. And so Florida has a couple of things going on in addition to the extra water and the thermal expansion. We've got changing ocean currents, and we have something called redistribution of Earth mass with ice melt. So let me talk a little bit about that for you. In this graphic, here's Florida. And you're watching the Gulf Stream. Look at that again. Here's the Gulf Stream. It's bringing warm water from the equator and moving it north, moving it all the way up to the Arctic. And you'll notice that here's the Bahamas. You'll also remember that the Earth is spinning. And if you picture a spinning bucket of water with water in it, you will notice that in the bucket, as you spin it, one side of the bucket, the water in the bucket, will be higher than the other side. It's that called the Coriolis effect. That Coriolis effect is spinning the Earth and spinning water away from South Florida and onto the Bahamas. And the Bahamas sea level is actually 3 feet higher than sea level on Miami Beach because of this Coriolis effect. This Gulf Stream is keeping that water pushed sideways so it doesn't come back to it. But all of the cold water melting off of Greenland is causing this current to slow down. Not going to talk too much about why that is, but the spinning Earth putting water to the east and the Gulf Stream protecting us from it coming back, and the ice melting Greenland slowing the Gulf Stream, the water's starting to slosh back our way. The other factor is shown here. Believe it or not, the Greenland ice sheets are so massive that they have a gravitational pull on the sea. So here's the ice sheet, here's Earth, and here's the ocean. The ocean is being pulled towards the ice sheet because of its huge mass. As the ice sheet moves, the ocean is going to fall there, and all that water, they're going to have a sea level drop, but all that water has got to go somewhere, and it's coming here. So we have two regional problems nowhere else on the planet has. We've got the slowing Gulf Stream allowing Bahamas water to come back, and we've got melting ice sheet reducing the gravitational pull on the water up in Greenland. So that's pretty bad. You already see an accelerated sea level rise. Honestly, I don't need to show you any more pictures of flooded A1A or any more pictures of devastated peninsulas. This was Hurricane Ike. Note that the maps are not incorporating storm surges into their effects. And so for those of you who, like me, have family and friends still in South Florida, this is important information they should have. Not telling you to tell them to move, but I am suggesting that you share with them they're not getting the whole picture when they're listening to the news. Here's the whole picture. It's the same chart we saw before, kind of looks the same. This is Dr. Wanless's research. He is saying, again, excuse me while I look sideways, he's saying that somewhere between a 20% increase on the NOAA global mean or 52% increase because of the drop in the gravitational pull and an extra 15% on account of the Florida current slowing down, we could be looking at, by end of century, not 5 to 8.2 feet, we could be looking at 12 to 13 feet above sea level. Now, okay, so we're not going to be alive, most of us watching this video are not going to be alive by then, but you're going to be alive by 2039. That's less than a mortgage cycle, or 2048, less than a mortgage cycle. And here you're looking at the possibility under a high scenario of a 3-foot sea level rise by 2048 or by 2049. 1 year doesn't make a whole lot of difference. So when people say, well, when is it coming? This is the possibility, business as usual. My point again is this is an emergency. It is urgent. That water will come. What are we going to do to make the situation better? Just want to recap what we've got. We've got ice, well, we had thermal expansion, of course. We've got ice melt. We've got the slowing Gulf Stream, and we've got reducing gravitational pull. I'd like to show you a graphic, again, Dr. Wanless's team, about Miami-Dade and Broward counties this century. And why does it matter to us in Gainesville? Because these folks, some of them are not going to stay. Some of them are going to say, like I did, I've had it. It's not going to get better. We can't hold the water back. South Florida is built on a limestone sponge. You can't build a seawall and expect it to keep the salt water out. And I want to point out why the inland areas are going to flood as well. All right, so here we go. Here's present topography. Those of you from South Florida will recognize Key Largo, Turkey Point, Homestead, Key Biscayne, Miami Beach, Miami International Airport. That's business as usual as of today. If we have a 2-foot sea level rise, which could be in the next, 15 years or 20 years, notice what's happened to Turkey Point. It's kind of sticking out there all by itself. Key Biscayne and Miami Beach are pretty well flooded. And notice what's happening inland. Let me explain what's happening inland. As sea level rises, this is not storm surge, my friends. This is sea level rise. As the salt water comes in through our porous limestone bedrock, salt water is dense. If you put salt water and fresh water together, the fresh water is going to float to the top. So as you raise the sea level inside the aquifer, you push the fresh water up. And notice I'm just going to get dramatic. At 6 feet of sea level rise, notice how most of western Dade County, western Broward County are underwater. They're not under salt water. They're under fresh water. There's a lot of fresh water there. So, and at 8 feet of sea level, which is the NOAA prediction for the globe, not the South Florida prediction, most of Miami is gone. You now have an archipelago, possibly reachable by boat. So I don't know how South Florida is going to adapt with this. You can't build enough seawalls. Maybe you can put enough houses on stilts. Maybe you can help people retreat upland instead of inland. Inland isn't going to do you any good, as you can see. So this is pretty sad. So let's take a breath. Now I will thank you. Thank you for hanging in with this. It is very hard to breathe when you understand what the future is likely to bring. This is a probable and almost certain future given business as usual if we don't change things. But let's dial it back. There's a lot of things in our power to do. So one more breath. Very good. And one more. Let's shift gears. Let's look at what is being done and what we can do. It is not hopeless. There are scores, even hundreds of actions, big and small, that we, our businesses, our communities, our country can take. We just have to take them. And I have an entire session called Solutions, 80 solutions around the world, and we can look at those in detail. But for right now, let's just take a look. By the way, I'm always eager to help you find your path, to share what you have learned here, to learn to do this kind of presentation, or to engage other groups in this kind of conversation. As I was kindly introduced this morning, I am in charge of presentation committee for Climate Reality Project. We've all been trained by Al Gore and Climate Reality Project International. And we are always happy to provide a speaker if you do not wish to be the speaker yourself. We can engage your faith community, your book club, your Thanksgiving dinner crowd. So just to take a look at what we've covered so far, just to recap, the water will come. Carbon dioxide is making us hotter. That heat is going into the ocean. The ocean is melting the ice coming from the north and from the south. Florida's been underwater before, and we're heading that way again. Our probable future business as usual doesn't look so great. What can we do? Well, let me give you a 2-minute trailer for a film called 24.
My name is Damon, and this is my daughter, Velvet. Her major concern right now is the elusive art of sleep direction. But soon, she'll have to face a rapidly deteriorating environment.
The ice sheet is now melting faster than the scientists predicted.
I think there's room for a different story, a story that focuses on the solutions to some of these problems. So in 2040, what will the world look like for our daughter? if we just embrace the best that already exists.
Instead of having governments that are reacting to disaster, we need governments and businesses that actually take us off in a different direction.
Maybe it's farming, or it can be energy, it can be housing, or empowering girls.
I'd like to see deforestation being stopped.
Oh, that would be so cool. That'd be awesome.
Just be respectful to Earth.
Imagine Velvet. We adopted regenerative practices like phrases, pulling the carbon into the soil and making it healthier.
That's right, yeah.
And we embrace efficient local energy.
Bangladesh has 5 million solar home systems. They have that power in their own hands. This is bringing people together.
But here I am sitting on an aeroplane that is spewing out carbon. You can't help but be a hypocrite because our entire system is built on fossil fuels.
What were you guys thinking?
Well, sometimes we weren't.
The power of innovation, imagination, creativity, to sit within all people.
People want to be working on something that they can see is actually helping to regenerate the world.
Everywhere you look, you will see incredible reasons for hope.
You could feed 10 billion people with the protein from marine permaculture alone.
Wow. Not only are there so many people who want to take part in telling a new story, we have everything we need right now to make it happen. What's your 2040?
I just want the future to be good.
That's just a snippet. Everything in the film is something being done already. And as I said, I've got an entire program on what is being done around the world, what we can do. We have the technology, we have the money. All we lack is the political will. So, but what can we be planning to do now? Well, one of the things for South Florida is start planning to save the things we can't afford to lose. Archives, museums, military bases, seed banks, computer data centers. You can read the list. I think one of the major things is this planning for rapid resettlement of large population groups. And that's where Gainesville comes in. There's also an issue of maintaining agricultural functionality and distributions. Homestead, Florida is a big ag area, and so is Lake Okeechobee, and so are the areas around Gainesville. We are facing, though, heat that's killing plants, pests that kill plants, a destroying of ecosystems to plant more food that also has some negative impacts. So really, there's a lot of work to be done locally so that we can protect our corner of paradise and welcome other people there. So what can you do? Well, you're already voting because I'm talking to you, Democratic Women's Club, and you are already working to get out the vote. But you can use your voice. You can write letters, you can tell stories, you can organize more speeches like this. You can tell everyone you know something you learned today you didn't know before, or something that startled you, or something that emphasized what you already knew. You already knew we have to stop burning coal, oil, and gas, but maybe you didn't really get the why. You do want to know your elected officials and candidates, and you want to push them to take climate change seriously. You do that already. Use your wallet. Shop sustainably. Shop locally as best as you can. If you're lucky enough to have an investment advisor and a portfolio, talk to him or her about investing green, and certainly about divesting your portfolio of all fossil fuel giants. You could also, don't hit me, join yet another organization consistent with your interests and your values. Laudato Si Circle if you're Catholic, the Clio Institute if you wish to learn more citizen science and then teach it to others, Sierra or Audubon if you love the outdoors or bird watching, the Garden Club if you get it, that all we have to do is plant wildflowers on the 6.6 million acres of grasslands in median strips and under transmission towers that would increase biodiversity and suck carbon out of the air. Call me and we can chat. Take a picture of the screen. I'm Ellen Siegel. My company is Woodstock Wisdom at atd.net. I do these programs at no charge because all I want you to do is talk about them. Text me, send a carrier pigeon if you like our smoke signals. So the choice is ours. We can do this. We can do this right now. What will you do? Go get them. So thank you for your time. I hope you found this video helpful and useful. Feel free to share it widely, and I will send this on to the chapter along with the 2 10-minute videos by Hal Wanless. I thank you for your attention and for coming and being brave enough to tackle this.